In Algebra 1, we learned how to solve simultaneous equations with 3 variables, and you learned how to solve simultaneous equations with 2 variables in previous years. Now we're looking at solving systems of linear and non-linear equations. Don't worry about that word systems. That just means we've got a couple of equations that we're working with. So linear and non-linear is the difference here. Everything we did up to now was linear. There were no higher powers, squares, or cubes. Okay. Let's have a little look. In this lesson, we're going to solve systems of linear and nonlinear equations, as I've said. We're then going to look at a graphical interpretation of what's happening here. So we'll do the algebra first, and then we'll look at the graphs and link the two together and see how points of intersection come into play. And then, as usual, we'll look at applying the technique to some fairly typical exam style questions. Okay, so first thing we're going to do is just learn the technique, how to solve these pairs of simultaneous equations. So what you'll see here is that we have got two equations, one underneath the other, like we're familiar with seeing from our previous simultaneous equations work. So let's see, what have we got? We've got a nonlinear on top, there's those powers going on there, and then you've got a linear on the bottom. And so the first thing we're going to do is we're going to start with the easier or the linear equation in this case. If I label these up 1 and 2. So I'm going to start with equation number 2, and we're either going to make x or y the subject. Your choice, whichever one looks easier for you. And then you sub that back into the other equation. Now there's more to it than this, but that's all we need to get started, and we'll be able to figure out the rest after that. So we're going to start with equation 2. So equation 2, I think I'm going to make y the subject. So I'm going to start with equation 2, which is the linear one. It looks easier to deal with, and we're going to make y the subject there. You could choose to make x or y the subject, but in this case, the y looks like it's going to be a bit easier. Okay, so the y is negative. I'm not so happy with that. So I might bring the y to the right, perhaps, add it on the right-hand side. And then that positive one I'll bring to the left and subtract it on the left. So there we have made y the subject. So then our second step was to sub that back into the other equation. So for this one, I'm going to sub this into 1. So equation number 1 is 3x squared minus y squared equals 3. I've written it down before I do the substitution because I'm afraid I'll make a slip. And now I'm going to sub in. I now know that y is equal to 2x minus 1. So instead of y, I'm going to write 2x minus 1. It's y squared. So y is 2x minus 1, and I need to square it, is equal to 3. Now, the reason I didn't write down any of the following steps is that I think that we can develop enough of an algebra instinct to kind of take us from here. So when we look at this, there's a bracket to be squared. Whenever there's a bracket, we should probably expand it. So we'll leave that as it is, minus 2x minus 1 times 2x minus 1 is equal to 3. I'm putting this in a big old bracket because I'm afraid that I'll forget that the minus needs to do its work in a little while. So now I'm going to expand the bracket. 2x times 2x is 4x squared, and minus 2x minus 2x plus 1 is equal to 3. 3x squared minus 4x squared plus 2x squared. I'm bringing the minus outside the bracket in, and it's changing the sign of everything inside. Minus 1 is equal to 3. I'm going to tidy that up a bit. Minus 1x squared plus 4x minus 1. Bring the 3 over. Minus 4 is equal to 0. It's a quadratic, a trinomial, a 3-term quadratic, and we know how to deal with that. So I'm not very happy with the leading term, the x squared term being negative. So I'm going to multiply everything across by minus 1 to change all of the signs. And then my leading term will be positive. Now I'm ready to do the trinomial. I'm just going to crack on with that. If you can't remember how to factorize trinomials, go back to Algebra 1. I've covered it in there. So I've got x equals 2 and x equals 2, the same solution twice. So basically, x is equal to 2. We don't need to repeat it here. So what was I trying to find again? I was trying to solve these equations, which means find the value of x and y. So I found x. Now how will I find y? Just scroll back up again. Look at this equation here. This is going to help us to find y. Sub into y is equal to 2x minus 1, which gives me y is equal to 2 times 2 minus 1. Y is equal to 4 minus 1. Y is equal to 3. So those are my solutions. X is equal to 2 and y is equal to 3. Okay, there's a good bit of work in that. The first two steps is all I need you to kind of lock in how to start. After that, hopefully you'll be able to just take it from there. So there's a question on the right for you to try. The top equation, it's not quadratic, it's just got x times y equals 4. Just stick with the process, stick with the plan. I would probably start with the second equation and maybe make y the subject, and then sub that back into the first equation and just take it from there. You'll notice here we got two sets of solutions. Now, when we get to the graphical interpretation of that, we'll see why this happens. But for now, we're just looking at the algebra. We've ended up getting two sets of solutions, which is very common when you're dealing with nonlinear equations.